We're going to talk about the API lifecycle, API versioning, API design principles, design patterns, and I need you to understand that these three are not exhaustive. So we're going to speak about GraphQL, REST, gRPC. We're going to speak about Open API as well. Keep an open mind. Finally, we're going to speak on security considerations. Come with me on this journey. We'll start with understanding API management. But more importantly, let's define APIs. APIs are simply commands that enable two backend systems to speak to one another. They are different specifications in terms of what goals we want to meet. One of the goals we might want to achieve is to search for an item, a name, or certain categories of people in a database. REST API, GraphQL, gRPC, they have their strengths. The idea is you need to pick the best one that enables you to meet your goal in a fast and efficient way, right? Efficiency, because at the end of the day, you're not trying to sleep here, right? When you build systems, you want to make sure that they're optimal. It is super important that you understand that every system, every mobile web system, they run on APIs. The way your features work with one another, they are APIs, really. And so I would use the typical use case to explain APIs. How many of you have used Ubers? Whenever you book an Uber, the Uber comes to you. When you start the ride, you look at the driver's screen and it shows either a Google map or say Apple map or whatever type of map you might have, right? How many of you have seen that? The reality is Uber does not own any one of these maps, but they are integrated with these apps. So whether that's Google Maps, Apple Maps, or whatever type of map, Uber has integrated into this service because they need this service to serve their customer being the driver, right? Because that makes the driver's navigation easier, right? So at the end of the day, when you think about features of an application, if you strip them apart, you realize, is it easier for me to build a product from scratch, or is it easier or optimal for me to integrate another service? You would agree with me that there are a number of things that are really important to every business. For example, Uber has a value proposition of taking people from one place to another, right? OpenAI has a value proposition of making sure you have literally everything you need in terms of information, data, right? Their core service is not to buy you a car or take you on a journey. If OpenAI wanted to offer that service, they might decide to build it on their own. And it might also be efficient for them to say, you know what, this is not our core business. There is a core business that does this, which is, for example, Mercedes, Tesla, right? We can integrate with these partner, and this partner would give the most efficient type of service to our customer because this is not our bread and butter. Now, do you see where I'm coming from in terms of features that are super important to the customer, the most efficient runway, and then you're bringing in that feature from a third party that has really done it well? This is the best use case for APIs, right? Now, with that understanding, I would move on to introducing what API management is. I like to think that API management is a couple of things involved. One of it is the building or the creation of the APIs. When you design and create an API, the next step is that you need to publish that API. If not, organizations or individuals cannot read what your APIs do if they needed your APIs to be able to execute on any value proposition they are searching for. They need to be able to read it somewhere. That's where documentation comes into place. You have another team under API management that speaks to security. Now, when you talk about security, you're talking about how you want to secure those APIs in order for bad actors to not intentionally try to use your data without seeking the right permissions or compliance. When we speak about monitoring, how do you monitor for either growth or whatever your use case might be? You might be monitoring for growth, you might be monitoring for, say, I just launched this new API. Is the functionality working? What's the uptime? What's the downtime? What are these metrics that I want to monitor for? Finally, we talk about maintaining those APIs. Through this topic of API management, we're going to look through each of these areas. So when we talk about creating, that is the design phase of your API. When we talk about publishing, that is the publication of your APIs, we're going to talk about securing your APIs, monitoring those APIs to be sure that they are doing what they need to do. And we're going to also talk about maintaining those APIs as well. The real value in API management is to make sure that these APIs that you have built, the idea is that you must build them in a consistent and scalable manner. Consistent and scalable manner means that any third party that wants to have a conversation with me, I am building without using things like internal nomenclature. I'm using verbs or nouns that enable the user to understand what they can do with that API. For example, if I built an API that enables me to collect payments, right? The name of that API, as I would give it, would be accept payments. The reality is that that's the action that the customer wants to perform. The customer wants to perform a payment acceptance. The different methodologies of accepting payments, you might have QR code, payment by link, open banking cards, and transfers, right? Now, the idea really is that use case, which is accept payment, the name of that API catalog will be accept payment. All of these different methodologies in terms of how you collect payments, the reconciliation, settlement, all of those endpoints will come as sort of embedded endpoints within that API stack. And that's what I mean by making it in a consistent and scalable manner. Because once it's consistent in that way, your users can see value in what you have done. And so for scale, it is easier to see how you can build upon that going forward. And we'll talk a lot more about scale in the following topics. Now, API management as a whole involves various sets of tools. It also involves various services that simply, and the simple goal is for organizations to be able to expose backend features to majorly developers. Developers are the customers when it comes to APIs. APIs are built and designed in a way that developers are sort of like the customers that sort of understand these APIs. They understand the methodologies behind these APIs. And I would go further to say that a layman who knows nothing about coding or API designs might not necessarily understand and appreciate APIs. And so the customer segment for APIs are truly developers. And really, this helps applications or external applications to maintain that process that is API management. Maintaining in the sense that you want to secure your APIs, you want to control, you want to have visibility over the usage of your APIs, which is what I mentioned in terms of understanding API management. And so pretty much the understanding here is, how do I manage these APIs that enable us to do as much work as we want to do? You have these fancy tools that can do XYZ. How do I manage these tools to actually perform these services or reach their full potential, so to speak? Which brings me to my next point. There are key components that enable this API management to work. And these key components are a few of them that I'd mention, and then we'll develop that as we go into the rest of the lessons. Firstly, and most importantly, is an API gateway. An API gateway serves as a bridge between your APIs or backend service and external parties. It typically acts as an entry point for all requests. On my left hand, you have clients. Clients are mobile applications, websites, different front-end devices. You have an API gateway in the middle, and behind this API gateway, you have backend services. There are different design patterns or different ways that they might build those. At this point, that does not matter. In this description, what you should understand is simple. There's a backend service, an API gateway, and clients. Every time a client seeks to retrieve or make a change to that backend service, that client request is sent through an API gateway. And there's a few things that an API gateway does with each of those requests. One, it handles the traffic. An application is not used by one user at the same time. There are many users that use an application. Let's give an example. A banking application, Barclays Bank, might have 2 million customers. On a Friday night, everyone is probably signing into their app to make a transfer or complete a payment, right? Or let's use end of the month when people get paid. People are trying to pay off bills at the end of the month. You would imagine with me that the traffic at that point would be, if Barclays has 2 million users, at least a third of that would be trying to make payments if they all get paid on the last day of the month, right? And that's what I talk about when I talk about traffic. Loads of people using the same service at the same time. And we'll talk about the scaling of those systems to accommodate those users. The most important thing here to understand is that when this traffic comes, this API gateway filters this traffic. First of all, it does something called authentication and authorization for all of these different requests. That authentication and authorization is two things. One, I want to authenticate that that user is actually who they say they are. Once I validate that they are who they say they are, I can only authorize them for a service that they've been authorized to use. Whether that authorization is identity authorization, whether that authorization is identity validation, whatever the authorization that is configurable by the bank, right, as they've created as their KYC or whatever, at whatever level, that authorization must be validated. Now, once those two are validated, once you're authenticated and authorized, then you are allowed to use that service. When you log into your banking application, an authentication happens that you are actually who you say you are using your user ID and passcode. The authentication happens. You can't even use your Face ID these days, but it's still the same format. And we'll talk about that when we talk about API security, how this works behind the scenes. Another important point is once that is done, you have a plethora of services. Whatever service you pick, you are now authorized. You are now, whenever you try to use that service, an authorization schema is going on behind the scenes. Once you have been authorized, that's fine. For you to complete that payment or for you to complete that the use of that feature, it means that you have been authorized to use that feature. Even if we had 1 million users trying to use the same service at the same time, What the API gateway does is more like, I would like to call it a division of labor. That backend service that 1 million users are trying to use, it will be you would agree with me that it will be an overload on the backend system for this backend system to have one server, and that one server needs to address the users or address the different unique payment IDs that all the users are trying to send on a Friday night. Remember my use case, on a Friday night, everyone is trying to make payments. So what happens behind the scenes on the back end is, for a system that has been built in an optimal manner, what happens behind the scenes is, if they don't have enough servers to sort of take that, what happens is that if the DevOps or the engineering team behind the scenes have built that in the right way, most times what happens is an horizontal scaling happens. Horizontal scaling simply means that we are replicating multiple servers that perform the same action as one of the servers, right? In order for us to accommodate these many users. Do you see what I'm saying? And so when 1 million users come into the system to perform the same request, what's happening really is two things. One, you've been able to say, well, I have been able to authenticate this user. I've been able to authorize this user. And I've gotten to this point where everyone needs to have this service. The idea is, once you've been able to spin those off, division of labor comes into place. If I have, for example, 500,000 different servers, or for example, I have 100,000 different servers, what happens is that because I have 1 million requests, I'm going to split all my requests to the different backend services. I'm going to have 10 requests per server. What that means is that everyone gets what they want at the same time, but we're not overloading the system behind the scenes. That is what I mean by managing traffic. To drive this home, I've explained the remaining concepts using the same example. The API gateway also handles the request when the traffic comes in and performs load balancing. It spins up different instances of the server behind the scenes, which is essentially what load balancing is. I want to make sure that each server is not overloaded. So you don't want a situation where one server is getting 100,000 requests, whilst another server is getting 100 requests. That's not feasible long term. What you want to do is you want to make sure that there is load balancing, which is where I introduced division of labor to your services. Now, remember where I started from in the use case. There is a client, an API gateway, and then there are backend services, or let's call them different types of servers, right? The concept is that the client is trying to retrieve information from this service behind the API gateway. The API gateway is securing, right? It is managing the traffic. It is handling the request. It is also load balancing. So essentially, if you take each use case and if you take each type of server and put it within this use case, it fits. Do you see what I'm saying? So, for example, an application server, it's running applications that clients use, right? A client is you and I that use Barclays Bank mobile applications, for example, right? I'm trying to access my money through my mobile application. But there's an API gateway that authenticates me that I'm actually a customer of Barclays. And then the service I'm trying to use, it authorizes me for that service, right? That is an application server behind the scenes, validates all of this. Similarly, with a database server, I am a client using Power BI to visualize data from a database. Between the database and Power BI, there is an API gateway. In this use case, I'm putting an API gateway to make sure that I'm securely passing this information from point A to point B. I'm also managing that traffic because in an enterprise system, it could cause chaos. All right. And so the idea here is that you want to conceptualize all of these things. There are different types of servers, but time would not enable me to explain each and every one of these types of servers to you at this time. There's a web server. A web server is the one that delivers web pages to a browser. So whenever you visit a browser, that web server is delivering all of that information. Whenever you enter a URI for the first time, it takes a bit of time to load. However, the second time you try to log on, it's a lot faster. In that situation, it has saved some of those icons. It has saved some of those icons that website comes with. And there's a web server that enables that. All right? There's a file server. File server just stores and manages files so that your users can simply just access whenever they need it. If an example of file server could be your Office 365. So basically, you store and manage your different files on SharePoint, right? You have mail server. There is all the information in your Gmail, Apple Mail, or iCloud Mail, Yahoo Mail. They are stored on a mail server because you are using that to send and receive information. A server is simply a system that provides resources, data, services, or programs to other computers known as clients over a network. If I send you an email, that information is sent through an email, whether I'm sending through Gmail to Yahoo Mail. The concept is I'm sending information between two similar services. I can't send information from a mail to a file. It's not going to receive it. Two people have to be able to communicate with one another because they are speaking the same language. With that being said, I just needed to land this point really clearly. Now, key components of API management, I've spoken about API gateway. The reason why I spoke about API gateway in that sense is because I want to make sure we have our foundations right. So down the line, when I speak on API gateways, I'm not going to explain them as much as I have in this context. Now, let's move on to the next point. Would you agree with me that I have established the point on API design and development when I said creation of APIs? The process of creation of APIs is basically using tools for defining and designing those APIs. For example, you have different specification types, but those specification types don't come into context except you decide this is the problem I want to solve. For example, I want to solve data retrieval. Data retrieval in the sense that I want to solve data retrieval for an application like Facebook, right? So the search engine on Facebook, or Amazon, the search engine on Amazon. What type of API specification would I use for that in that use case? Because it's a search service, right? I'm thinking my users want to be able to request type product and it's giving them the different types of product. I don't want the different families of products, right? So I'm looking at the different types of API specifications and I'm thinking, this type of specification doesn't necessarily do that job for me by giving me a pointed answer because it is resource-based. And now I'm speaking about REST APIs. For GraphQL gives you the exact information that you need. So in this use case, because I'm trying to do data retrieval, GraphQL is my best bet for building that search optimization, so to speak, on an Amazon or a Facebook. In fact, GraphQL was actually developed by Meta. for this purpose. The concept here is that you want to design your APIs based off of what the problem is. And I believe in retrospects, in other lessons, you would have understood or picked up that there are different patterns or different languages or different concepts that are being used. You need to make sure that you're customizing it based off of the needs that you have. Simple. So, to make sure that you are sort of choosing the right specification, right, you need to make sure that you understand the problem properly. There are different API design types, and you want to choose the one that best fits the problem you're trying to solve. When you choose that, make sure that you have well-structured documentation for that API, no matter what it is. Other consideration is security. Security, I've spoken about API gateways already, and so I'm just going to jump to what they do. Security as a concept is simply you want to protect your APIs from unauthorized access through simple mechanisms like authentication and authorization. There are various tools that you can use for authentication and authorization. They include OAuth, API gateways, API keys. I'll talk about these in further lessons. Authorization, rate limiting, encryption. We'll talk about this a lot more. Now, moving on, rate limiting and throttling, they sound almost like the same, but they're a bit different. Now, rate limiting simply is the concept of, I'll give you a use case scenario. I want to limit the number of API calls I get from a particular user, right? In the space of an hour, I want to make sure that based on their compliance level, I cannot have more than 20,000 API calls from this user in an hour, right? So there must be a time bound for rate limiting. Secondly, for throttling is like you're reducing the speed at which something happens. So throttling is, say, you're making API calls to me. I'm accepting those API calls, but the response time on my API responses are throttled. And all of these two concepts, that is rate limiting and throttling, are two concepts where they sort of prevent abuse and overloading of backend systems, right? So whenever you're trying to limit the rate at which people call you per time, it's really just trying to prevent abuse. If you're throttling, it's another methodology for just trying to make sure that you're not overloading the system, or you're just trying to prevent bad actors from abusing your system, so to speak. Another point in terms of key components of API management is analytics and monitoring. I want to be able to, first of all, monitor. And based off of the monitoring I've put in place, say observability using different toolings we have across the world today. So examples of those kind of tools is things like you have monitoring tools like, or observability tools like Grafana. You have tools like New Relic, right? These tools, they help you understand what's going on behind the scenes. The analytics part of this is more so like you've been able to extract this information. Now you're now building sort of like stories around it. I'll give you an example of when I used to work at a fintech. Because of the wide range of users or personas that we had in this fintech, we understood the different types of user behaviors. And I understood that there are certain banks that perform transactions no less than $1 million. And there are certain banks that perform transactions no more than $200,000. It's a pattern that has happened over time. So basically, that's my data story. At the end of each month, once I look at the data for that month and I see tier one banks doing anything below the $1 million mark, I need to see if there was a downtime. If there was no downtime, then it's either the tier one bank is moving away from my business, or they've gotten another provider to provide this service, right? And so what your data does and what analytics does for you is for you to be able to capture that very quickly. You can now start to say, call on your sales agents, call your customer success managers to say, I noticed this pattern. Kindly follow up with this customer. Kindly have conversations with this customer to know what their burning problems are. Or say, this problem has occurred. I want to validate that this problem is actually true. If you don't have monitoring and you don't have analytics, you cannot tell these stories and you start to lose users. They help you understand your user behavior and how and where and when to optimize your API. The next point is on the developer portal. Now, what's really important here when we talk about the developer portal is this is the home of the developer, so to speak, where they get to play around, test APIs, they get API keys, they're able to test APIs, they're able to read the API documentation, they're able to view their usage metrics, they're able to manage their APIs as well. This is really important for developing that engagement between a company and the developers themselves, which are the users of your APIs. Next point is on lifecycle management. Lifecycle management is super important for every business that wants to do APIs. In further lessons, we'll use a pyramid to explain the API lifecycle from designing and defining your APIs to retirement. It's really important that you have a good sense of what this lifecycle management means when it comes to the entire lifecycle of an API, from creation, versioning to deprecation and retirement, needs to be smooth. That transition needs to be smooth. So when you version, that versioning part is super important. I'm going to try to lay on this morning is versioning is so important that you can lose customers by not versioning properly and not communicating properly. So you might have done the most brilliant job by versioning an API, right, in terms of its technical work. But when you don't communicate that, it's done. So to simply put, this process is super important to, one, build the right tools, that is, version properly, use the right tools to version these APIs, but more importantly, the communication of that is literally the make or break of everything. In fact, the entire process is really the make or break of everything, because you need to transition users from point A to point B, that is a version 1.1 to a version 1.2, and you need to show them the value proposition in what you're trying to do. The next point is on monetization. Every business needs to make money. When you're managing an API, you need to think about the commercials around the API. This is something that might not jump out to you at first. This is actually how you define junior PMs from senior PMs when it comes to monetization and when it comes to the commercials of APIs. Because the commercial part of APIs is super important. Just to give a brief, it includes billing, tiered pricing, the different ways to generate revenues from APIs. Now, we also have captured the key components of API management. I think it is really beneficial for us to talk about the different benefits of API management. Why is it important to us? A few points. One is security. You want to ensure that an API is secure and it's protected from unauthorized access and attacks. Security, API security is super important because you want to prevent bad actors from accessing your backend systems, whether that is a database server, whether that's an application server, whether that's a web server. You want to make sure that you are well protected. Second point here is scalability. In API management, one of the benefits is it improves scalability. It enables APIs to handle increase in traffic and demand without degrading your performance or the performance of the API. This is super important because, as I did mention when I spoke about the traffic that comes at certain periods in time, if certain measures are not put in place, for example, horizontal scaling, users, at least a ton of users trying to use that service at the same time, will not have the best user experience due to degrading performance. All right. The next point is visibility and control. It gives you full visibility and control of your APIs. It gives non-technical users and technical users clear insights as to how the APIs are being used and who is using it, how they're performing. It just gives you that visibility of, look, this is how our payments APIs are performing, this is how our identity APIs are performing, this is how cost, whatever types of APIs are performing. Another point is developer experience. It gives you a very good developer experience, but where you offer clear documentation that supports your users. Your users naturally are developers. It enables simpler integrations for third-party developers because once they have clear documentation, it's easier for them to navigate your system.